Okay, so this one would be, I mean, it's the same concept. It's an equilibrium constant, but it's related to solubility of a substance. That's known as the solubility product. And so it's known as the solubility product, or you can call that KSP. And remember, it's all related to the solubility of a substance, any substance actually. And we're mainly talking about ionic compounds here. So we're talking about compounds that dissociate in aqueous state. So what happens is that if I have a big beaker, and the beaker has a lot of these ions. Let's say it's got NaCl. So it's got a bunch of sodium ions, it's got a bunch of Cl ions, and they're all, so positive and negative ions, they're all sticking together. So positive and negative ions are all sticking together, and this is what happens when you try to dissolve NaCl. Positive, negative ions, positive ions, negative ions. That's what an ionic compound looks like. Oppositely charged ions, and you've mixed it in water. Now, when it's in water, the substance will dissociate. So some of these ions will break free from the lattice, and they'll float away, which means that they will dissociate. They will become aqueous ions. So the lattice will start dissolving, and slowly, one by one, all these ions are dissociating. But up to a certain point, there will come a point where the solution will become saturated. That means there'll be too many ions in the solution. So all these ions are dissociating, the ionic lattice is dissociating, but the dissociation will happen, and it will happen. So this is positive, negative, all these ions breaking free from the lattice. So the dissociation will happen, and this is, if I write an equation for this, the equation will be that NaCl, the solid ionic lattice, it is dissociating into its aqueous ions. It will become Na+1 aqueous surrounded by water, and it will become Cl-1 aqueous, and that too is surrounded by water. So it will keep on dissolving. It's a very soluble substance. So
sir,
हाँ जी,
सर आज आपने कहाँ से स्टार्ट किया?
मैं solubility product बता रहा हूँ ना.
Okay, sir.
So I'm just saying this is what happens when NaCl dissolves, right? An ionic lattice, it dissociates into aqueous ions. But then the reaction will become reversible. It will become reversible when the solution is completely saturated. Saturated, hopefully everyone knows what saturated is. Saturated is when no more salt can possibly dissolve. So there would come a point, like you add 1 tablespoon of NaCl, you add 2 tablespoons. Third or fourth, if you add the third and fourth tablespoon, the NaCl will kind of stop dissolving, and the solution will become very, very saturated. And at that point, what will happen is crystallization will start happening. Your salt is the solution is so saturated that instead of the ions leaving, the ions, they form the crystals back again. The negative ions will start joining with the positive ions, and the crystal will start growing. So a reversible reaction will happen. Some of the ions will dissolve. So maybe this positive ion might dissociate, and it will travel away. But at the same time, some other negative ion will get attracted and will join up with the positive ion. So another negative ion might join up. So crystallization is also happening at the same time. Maybe another positive ion, it dissociates in water, it becomes aqueous. But at the same time, some other positive ion will form part of the will become part of the crystal lattice. So now your reaction is reversible. And remember, this only happens once the solution is saturated. So now you've got a double arrow. That means it's moving forward. It's also moving backward as well. Some of the ions may be dissolving. They'll be breaking free from the lattice. But at the same time, some other ions will be becoming part of the lattice. They'll be joining up because the solution already has too many ions. So it can't hold that many ions. So the crystal will be dissolving and crystallizing at the same time. And that's a reversible reaction. But reversible only when it's saturated. Be clear about sound reversible. So there's this clear. Jan, Alicia. So reversible only when solution is saturated.
Sir?
हाँ जी.
सर अगर ये completely saturated हो जाए तो बाकी salt नहीं add कर सकते हैं?
नहीं वो करते रहोगे, but it will be a reversible process. Na? Like if the solution already has too many ions, right? तो इतना saturated हो चुका है कि even if you try to dissolve more of the salt, ठीक है, maybe this positive ion dissolves and leaves, right? So some other positive ion will, because the solution already has too many ions, so it will form part of the crystal. So the net quantity of ions in the solution will become constant. Is that clear? So a saturated solution will hold a constant concentration of sodium ions and Cl ions. It cannot increase. You try to add more salt, you try to mix it, some negative ion breaks free, but what will happen is some other ion will become part of the crystal. It will crystallize. So crystallization and dissociation will be happening at the same time. Clear is this part? I mean, is this clear? Anna? See, Shyam, clear?
Yes, sir.
So anyway, so this applies to all ionic compounds. They will dissolve up to a certain point. At a certain point, when the solution becomes saturated, they'll stop dissolving and they'll reach an equilibrium. So, and you can write this equation for any ionic lattice. So what if I have another compound, let's say K2SO4, it's going to have a similar equation that K2SO4 will dissolve. The solid ionic lattice K2SO4, it will dissolve, but up till a certain point. At a certain point, it will dissolve, it will form 2 K+1 ions and it will form 1 SO4 minus 2 ions aqueous. Now, what happens is that at a certain point, the solution will become, the whole reaction will reach equilibrium once it is saturated. Only when it is saturated. Otherwise, it's not going to reach equilibrium. It's got to be saturated. As if I have another compound like aluminium carbonate, so that will be Al3, CO3 minus 2. Sorry, Al will be 2. Al twice and CO3 will be thrice.
Sir?
हाँ जी.
सर ने कहा सैचुरेटेड वो होता है कि जब सारा सॉल्ट हो चुका होता है सॉल्यूशन.
जब सॉल्यूशन में और सॉल्ट डिसॉल्व नहीं हो सकती.
ओके सर.
क्योंकि उसके आयंस की कंसंट्रेशन बहुत ज्यादा हो जाती है, ठीक है. But there's going to be a certain limit. Beyond that point, you can't add more ions into the solution. So aluminum carbonate will dissolve and it will become saturated. So it will form Al plus 3 aqueous and CO3 minus 2 aqueous. And there'll be 2 aluminum ions and there'll be 3 carbonate ions in aqueous state. But once it reaches a saturated state, it will become reversible. So then every salt will form a different amount of ions. Like NaCl is really soluble, but aluminum carbonate is not really soluble. Now there's a reason for that, and the reason is that it depends on the strength of the lattice. If the positive and negative ions had a large attraction, then they would probably join up with the, imagine So the concentration of the ions in the solution, it all depends on how strong the lattice is. If the lattice, the crystal lattice over here, if you've got a very strong attraction between positive and negative ions, then what will happen? All the positive ions and negative ions will join up and they will form the crystal. The solution can, you won't have a lot of ions. I mean, this negative ion is very strongly getting attracted to the, so let's imagine the negative ion is getting very strongly, so it gets attracted to these positive ions. Then it's more likely to form the crystal. I mean, the positive ion gets very strongly attracted to the ionic lattice. This negative ion is very strongly, it gets attracted to the positive ion over here. So what you're seeing is the crystal forming. Now, if the lattice is very strong, there's a very strong attraction between positive and negative ions. So you won't have a lot of ions in solution to begin with. So aapka jo saturated state hogi na, it won't have a lot of ions. And the substance will not be very soluble. मतलब अगर वो एक दूसरे को इतना strongly attract कर रहे हैं, so they're not going to form a lot of ions to start with. On the other hand, if you have a very weak lattice, so what will happen? The positive and negative ions are not attracting each other very strongly, so they will dissociate more and they'll produce more dissociated ions in solution, right? I mean, they'll break away from the crystal lattice. This positive ion will escape, and there'll be the solution of the concentrated of the ions in solution will be higher. So it all depends. Solubility depends a lot on the strength of the lattice. Stronger lattices dissociate less. I mean, their ions are really not going to dissociate it. So stronger ionic lattices usually dissociate less. Why? Because it's very hard for the ions to actually break free from the lattice. What determines the strength of the attraction? The strength of the attraction between ions. It depends on two things. It actually depends on one thing that's known as charge density. So it depends on basically just one thing, which is charge density.
The charge on ion and size of ion.
Okay, so if you have a bigger charge on the ion, then obviously it's going to be a stronger attraction. Like why is aluminum carbonate not very soluble? Why will it not produce a lot of ions? Because aluminum is +3, carbonate is -2. So unke beech mein the force of attraction is going to be really strong. So it won't produce a lot of ions in solution because the ions will be sticking together and they'll be forming a crystal, and it would be a very strong lattice. It would be very hard to actually break them free, right? Ab yahan pe NaCl dissolves more. Why does it dissociate more? Because Na is +1 and Cl over here is -1. So +1 or -1 ek dusre ko itna strongly, they don't attract each other that strongly. So that means it would be a lot easier for them to actually dissociate and scatter in water rather than forming the crystal. So NaCl ki jo ions hoge na, uski concentration saturated solution will be higher. Aluminium carbonate ions and their concentration in saturated solution is going to be a lot lower. ठीक है, ये idea clear है? और मैं थोड़ा सा, is this
Yes,
part? And I'll explain charge density. So charge density depends on two things. One is the charge, like you've got greater charge, then obviously there's going to be stronger attraction. The other one is the size, ionic radius. Chota ion jo hoga na, that they would be smaller ions will be closer to each other. So since they will be like closer to each other, they'll have a lot stronger attraction. So you either have greater charge or you have a smaller ionic radius. Ya phir dono. That would lead to a higher charge density, and that will lead to stronger attraction between ions. Or agar stronger ionic lattice hoga, then there'll be fewer ions in solution and there'll be more of the crystal. Okay. So the idea clear hai ke every ionic compound will have a different concentration of ions in solution. Is that clear? Is that clear?
Yes, sir.
Sana, Umar, Rasim, Abia, is this all clear?
Yes, sir.
So that's the idea. So just remember this fact that every ionic compound will produce a different concentration of ions when you mix it in water. Now coming back to what is KSP? Now this is a reversible reaction, and I told you it is only reversible if it's saturated. Agar to wo saturate nahi hai na, it's a one way. It's going to be one way. Like if you're dissolving a small amount of NaCl in water, it will just dissolve. It won't crystallize back. It will only crystallize once you reach saturated. Okay? Forward, backward will reach equilibrium only when it is saturated, when no more of the ions can dissolve. Okay? So that's the only point when it's when this thing is at equilibrium. Now, since this is equilibrium, there's going to be a Kc, and that Kc is basically KSP. It's known as the solubility product. What is Kc? It's product concentration divided by reactant concentration. I mean, just your normal average Kc, right? So in this case, what will be your expression for Kc? Like, I mean, it's just your normal Kc expression. It's going to be aluminum ion concentration. That's your product. And that thing is going to be squared. And it's going to be your carbonate ion concentration. And that thing is going to be cubed. Okay, hopefully everyone remembers K. The coefficient becomes your power and divided by the reactant concentration. Now, your reactant is a solid, aluminum carbonate, which is solid. The solids की concentration जो होती है, that's taken as 1. I mean, they have constant concentration. So what you do is you don't actually write solids in your expression. So KSP expression is just the product of your ions and their concentration. Solids are always taken as 1. Their concentration is taken as a constant. Okay. Are you clear? This is your KSP expression. Is this clear?
Yes, sir.
Yes, sir.
Or I mean, the first thing is they'll ask you for the KSP expression. They'll ask you for the unit as well. And that's just your normal Kc expression. There's nothing different. So KSP is just Kc applied to an ionic compound dissolving in a saturated solution. So what will be the expression for what will be the unit in this case? It's going to be concentration squared. So I'm going to take x squared into concentration cubed. So it's a concentration to the power of 5. What is concentration? That's mole per dm cube. So it's mole dm minus 3 to the power of 5, which then becomes mole 5 dm minus 15. And your dm becomes minus 15. Okay. So that's your KSP basically. So iska bhi nikal lete KSP. Let's try and figure out the KSP for this one over here. Again, it's the KSP expression for this thing will be potassium ions will be, the concentration will be squared, and SO4 minus 2 ion and their concentration. Okay, you don't write the reactant because that's taken as 1. That's a constant. So this time it's concentration squared times concentration. So it's going to be mole per dm cube, and the power is going to be 3. So mole 3 and dm is minus 9. Okay, that's your KSP expression in this case. And this one, NaCl, that's a simple KSP expression. It's going to be, so it's going to be sodium ion concentration multiplied by Cl minus 1 concentration. And the expression is going to have, it's concentration times concentration. So it's mole squared and dm minus 6. Okay, clear? Is this clear? How to write the expression? Is this clear?
Yes, sir.
So that's how you write the expression. So what type of questions will they give you? First thing, they'll just ask you to find KSP, right? So that's the first question. Okay, just like your KC questions. So first question, first example question, that's going to be find KSP. Okay, it's not going to be, most of the questions are going to be kind of easy. So they'll ask you to find the value of KSP. Given solubility, now solubility could be given in mole per dm cube. It could be given in gram per dm cube as well. Solubility is the amount of substance that it's the concentration of the substance in a solution. So it's the amount that has already dissolved. Concentration of a substance in a solution. Now remember that it's not the concentration of the ions. Remember that. That you're going to find out yourself. It's I'll explain this part, but first thing, concentration, remember, is given in two forms. One is it's either given in grams per dm cube or it's given in moles per dm cube. I mean, most of the time it's given in mole per dm cube. That's what concentration is. But just remember, just in case, it can also be given in gram per dm cube. How do you convert gram per dm cube to mole per dm cube? What you do is you divide by the molar mass. You divide by mr, the mass. How do you convert mass to moles? Divide by mr. So जो mass है ना, that gets converted into moles. So if they give you 10 gram per dm cube about something, you just divide by mr, you'll get the same value in mole per dm cube. And we are actually more interested in mole per dm cube. Our entire KSP is actually mole per dm cube. Okay? So remember this conversion, that if it's given in gram per dm cube, you can just simply convert it into mole per dm cube by dividing by mr. अच्छा अब क्या होगा कि this thing, I had to explain this. So I told you this, the solubility is the concentration of the substance, not of the ions. Let me explain. What they'll say is, okay, for example, K2 about K2CO3 or any other thing. Let's talk about K2SO4. So they'll tell you about the concentration of the whole substance, that the K2SO4 in aqueous state, its concentration is given. And they'll tell you that it's, let's say, 1.25 mole per dm cube. Right, so maybe that's given. So it's the concentration of the whole substance, not of the ions. You can find the concentration of the ions by looking at the substance, like K2SO4, right? So they're saying that this is the amount of K2SO4 that actually dissolves in water. So when it dissolves, how many ions will it produce? It's going to produce 2 potassium ions, and it's going to produce 1 SO4 minus 2 ions. Okay, so remember, they've actually given me the concentration of the aqueous solution. So if this is 1.25 mole per dm cube, this thing, so how many potassium ions will it produce, since he's saying that this is the amount of the substance that dissolves in water? So if one dissolves, 2 potassium ions are produced. So the concentration of potassium ions will be double that amount. It's going to be 2.5 mole per dm cube. And the concentration of sulfate ions will be, it's 1:1. So that's going to be 1.25 mole per dm cube as well. So यहाँ पे एक चीज मैं clear कर दूं कि this is, over here, we're not talking about the crystal. The concentration is given for the substance that has already mixed in water. So अगर वो कहता है ना K2SO4 aqueous, that means this is the amount that has already dissolved in solution. So based on the ratio, you'll figure out how many ions, how many individual ions will you have. तो अगर K2SO4 mix होता है ना 1.25 mole per dm cube, so that means 2.5 mole per dm cube potassium ions will be present in aqueous state, and 1.25 mole per dm cube sulfate ions will be present in aqueous state. So is this idea clear? The concentration is given for the whole substance, not of the individual ions. Is that clear? But from that you can find the concentration of the individual ions as well. Is this part clear?
Yes, sir.
Yes, sir.
So अब वो KSP निकालना है. What is the expression for KSP? Now you know what how much ions do you have in saturated solution. You already did the KSP expression. That what was your KSP expression for this thing? It was potassium ion concentration, and that was getting squared, and SO4 minus 2 concentration, and that's power 1. You can just plug in the values. So it's going to be 2.5 squared, and it's going to be 1.25 power 1. और इसका जो यूनिट होगा that's going to be mole cubed dm minus 9. So all you have to do is इसकी मुझे वैल्यू बता दो. What do you get?
$7.8.
ठीक है. So we are getting 7.8 mole 3 dm minus 9.
सर
हाँ जी.
सर अगर K2SO4 aqueous में तो उसको कंसिडर नहीं करेंगे.
नहीं मैं वही कह रहा था ना, ये equilibrium जो है ना वो ये वाला है. It's I mean this is your equilibrium. Let me explain this. ठीक है. K2SO4 is solid है. ठीक है. Just one second. I mean that's your equilibrium. Remember K2SO4 is not 1. K2SO4 जो है वो तो solid है. ठीक है. That's your equilibrium. It's a solid. Solids they don't have a concentration, right? What I'm trying to state here is कि वो जो concentration देगा ना, it's not going to give you the concentration of the individual ions. It's just going to say that this is K2SO4 aqueous 1.25 mole per dm cube. That means this is the amount that has actually mixed in water. ठीक है. तो अब रेशियो लगा लो कि भाई एक potassium sulfate जो है that produces 2 potassium ions. So the potassium ion concentration will be 2.5 mole per dm cube, and the sulfate ion concentration will be 1.25 mole per dm cube. So वो जो concentration देगा ना, it's going to give the concentration of the whole substance. Using that, you will try and figure out the concentration of the individual ions. तो ये बात समझ आइए कि
Yes, sir.
ठीक है. तो वो equilibrium के अंदर ना ये तो crystal है. The concentration will be given for the whole substance, and that is the amount that has mixed in water, and that has dissociated, and that has formed ions. ठीक है. तो इसकी तो concentration होगी वो तो 1 होगी. So that's how your question. Or it's like we'll try and do some questions. That's question number. That's type 1. ठीक है. Where you have to find the. So where you have to find the KSP. So यहाँ पे देख लेते हैं just a second. So KSP questions. So we have calculated the numerical value for KSP, right? So this question, let's try and do this question. ठीक है, simple हो, इतना complicated नहीं होगा. So first thing is ALF3, right? So they didn't give us an equation, but I'll work that equation out myself. ALF3, that's solid. In a saturated solution, it's going to be in equilibrium with its ions. It's going to form Al3 plus when it dissociates, and it will form 3F minus 1 ions in aqueous state. ठीक है. अब ये कि what do you do after that? the expression, it's going to be Al3 plus concentration and F minus 1 की जो concentration है, that's going to be cubed. So that's about it. Now he's saying calculate the value of Ksp. उसने concentration दी हुई, that's 6.5 times 10 power minus 2, right? That the concentration of the saturated solution. So 6.5. So that's the amount that has actually mixed in waters. What is the concentration? It's the whole thing, 6.5 times 10 power minus 2 mole per dm cube. So ये वो amount है जो solution में dissolve हुई है. So how many aluminum ions will be produced? It's going to be exactly the same. And how many fluoride ions will be produced? That's going to be 3 times that value. So it's going to be what? इसका 3 times करो क्या बनता है? That's 19.5 times 10 power minus 2. Mole per dm cube, and this is mole per dm cube, right? And now I'm going to plug those values in the expression. So my Ksp expression will be aluminum ion concentration, that's 6.5 times 10 power minus 2. ठीक है, ये ऊपर वाला expression है, इसमें I'm plugging in the values. And it's going to be 19.5 times 10 power minus 2, and that's going to be cubed. So you've thought, what is the value that we are getting for this?
It's 4.82 times 10 to the power minus 4.
So it's minus 4?
Yeah, minus 4.
Minus 4 में मुझे doubt है.
Sir?
Minus 4, Alicia. अच्छा, सागा minus 4 आ रहा है. How is it minus 4?
Sir? Sir, fluoride का जो है वो 0.195 आ रहा है.
नहीं, वो वही बनता है ना, मैंने तो वो वही है. So ठीक है, it's minus 4. I think it's minus 4. अच्छा, 4.82. अच्छा, वो 19.5 था उसमें. ठीक है, that's why it's minus 4. And what is the unit? That's going to be mole per dm cube to the power 4, right? Mole 4. And minus 3 times 4, that's minus 12. ठीक है, that's going to be a unit. अच्छा, एक और थोड़ा सा tricky question कोई, ठीक है? So अच्छा, this 2 is not that tricky. It's just the same. But we'll do the whole question this one. अच्छा, इससे आगे ना, there's often they ask questions about moles using this. Now over here they're saying that write the expression for the solubility of Ag2S, right? So Ag2S, what is the equation? Ag2S solid, and that's going to be in equilibrium where it's going to dissociate. Ag plus ions banenge, 2 banenge, and that's going to be aqueous, and it's going to produce 1s2 minus 1 ions, and that will be aqueous as well. So expression will be silver ion concentration, and that's squared, and it's going to be S minus 2 concentration, and that's power 1. Yeah. अब वो कह रहा है कि the solubility is given of Ag2S, that's 1.16 times 10 power minus 17. So if 1 Ag2S dissolves, the silver ion concentration will be double this amount. So it's going to be, it's got double color, 2.32 times 10 power minus 17. Or S2 minus itna hi hoga. That's going to be 1.16 times 10 power minus 17, right? तो 2 double silver ions banayega, so it's going to be double that amount, and you can plug in the value. So you're supposed to find the value of Ksp. That's going to be 2.32 times 10 power minus 17, and that's going to be squared, or 1.16 times 10 power minus 17, and that's going to be power 1. तो आंसर हमारा -51 है. 6.24 times 10 power -51. ये चेक कर ले कि यही आ रहा है कि नहीं आ रहा. 6.24 times 10 power -51, and the unit for this is going to be moles cubed हो जाएगा. ठीक है, it's going to be mole cubed, and dm is -9. ठीक है, so you've found your KSP value. So that's a very small value of KSP. अब आगे वो कह रहे हैं calculate the minimum volume of water needed to dissolve 1 gram of Ag2S under standard conditions. So we figured out that they've already told us that the solubility is given, that's this much. It's 1.16 times 10 power -7 mole per dm cube. इससे ज़्यादा dissolve नहीं होगा. 1.16 times 10 power -17 mole per dm cube. So they've given us the concentration, right? Okay, this is the amount of Ag2S, maximum amount that will dissolve. And he's asking me कि भाई कितना volume required है. Now what I can do is I can find moles because it's 1 gram of so based on mass I can find moles. Mass divided by molar mass. So 1 gram divided by the molar mass of Ag2S. Eg I think is 107.9. वो देख लोगे क्या है. Silver atomic mass 107.9 है. ठीक है, that's silver. वो times 2 है. Plus sulfur is 32.1. So how many moles do we have? क्या value is क्या? 100 plus 32, that's 140, I guess. 1 divided by 140. Sidra, Lisha, ना क्या moles आए? So we're getting 4 times 10 power -3. So we're getting 4 times 10 power -3 moles. Actually, anyways, that's a simple moles question. Okay, they gave me the mass and I was able to figure out the moles. And right, and I already know the concentration. So volume of the solution क्या होती है? Moles is concentration times volume, right? So I need to figure out volume. Volume will be moles divided by concentration. So it's going to be 4 times 10 power -3 moles. And the whole thing gets divided by moles divided by concentration. So the concentration is 1.1686 10 power minus. हाँ जी.
सर इस तरह से कर सकते हैं कि अगर 1 मोल 24,000 सेंटीमीटर क्यूब के तो उसके लाइक कंपैरिजन कर लें.
नहीं, पहली बात है कि वो जो 24,000 सेंटीमीटर क्यूब है वो गैसेस के लिए. ठीक है, रिमेंबर ये whenever they talk about volume, ये थोड़ा सा सोच लिया करो कि is it volume of the solution or is it volume of the gas. In this case they're talking about the solution. ठीक है,
यस
तो वो गैसेस के लिए. अच्छा खैर, इसके साथ they'll probably ask you about a few moles question as well every time. So we already knew the concentration of silver sulfide that can exist in a solution, and based on that they gave me the moles as well, so I was able to figure out the moles. Then if I know the moles and concentration, I can obviously figure out the volume of the solution as well. तो बस आंसर बता दो क्या आ रहा है इनमें. तो है अच्छा ठीक है, वो 3.47 times 10 पर एक बड़ी वैल्यू नहीं अंश है.
So 3.47 into 10 to the power 14.
Plus 14. make sure you use brackets, ठीक है? I guess it's going to be plus 14. ठीक है, तो ठीक है, ये फिर कल कंटिन्यू करते हैं. बस ये KSP का ना एक टाइप का क्वेश्चन है. We'll do the other type of question as well, which is where KSP will already be given. So reverse में ना you have to do everything in reverse. ठीक है, so we'll do that tomorrow.
Sir,
हाँ जी.
सर वैसे लाइक ऑफ टॉपिक क्वेश्चन है सर, ये पिछले वाले के साथ रिलेटेड है जो पिछले जो इक्विलिब्रिया कराया था?
नहीं, उससे कोई इसका रिलेशनशिप नहीं है. वो मैं पहले कह चुका हूँ उसका. वो सारा वीक एसिड से था. ये दिस हैज नथिंग टू डू विद दैट.
सर वैसे जो आपने जो पिछला जो कराया था सर, आप उसकी लाइक कंप्लीट लिंक भेज सकते हैं जो मतलब अभी आपने खत्म कराया था इक्विलिब्रिया का?
वो उसमें है ना, वो जो वो शीट, ये वाली शीट नहीं खुलती तुम लोगों की, ये जो भेजी हुई है. एक सेकंड, आई डिड सेंड वो परमिशंस मांगते रहते, लेकिन आई थिंक इसकी परमिशन मैंने वैसे ही अलाउ की हुई है. इसके अंदर जाना, ये जो कॉपी ऑफ यूट्यूब के वीडियोस है, ठीक है, देयर इज इसके अंदर सारे वो लाइव क्लासेस के वो आ रहे हैं. जस्ट वन सेकंड, इसको अगर मैं 50% करता हूँ ना, तो यहाँ पे दिस ये वाले स्टार्ट हो जाएंगे. दिस इज ऑल वो डेट वाइज चल रहा है, ठीक है. तो यहाँ पे 13 सितंबर तक ना दिस इज देन अपडेटेड, ठीक है. तो वो ये सारे लिंक्स इधर ऐड हो रहे हैं और ये लिंक सारे ओपन होने चाहिए.
ओके सर.
वरना वो फोल्डर का भी मैंने भेजा हुआ है. ये मैं फिर शेयर कर देता हूँ, ठीक है. चले, ओके.
ओके सर, अल्लाह हाफिज़.